Once more, you're back with first year undergraduate microeconomics. In this video, we're going to start looking at our price-taking firm and asking, when does it make a profit and when does it make a loss? And that's going to depend on whether we're in the short run or the long run. So let's start off by thinking about our price-taking business and looking at profit maximisation in the short run. Remember that the profit for a firm is simply revenue minus costs, and that revenue, well, it's simply price times the quantity that the business sells. And as we're talking about a price-taking firm here, this price is just going to be fixed. It's not going to depend on the quantity. So we're going to know that our marginal revenue, the extra revenue when we sell an extra unit, well, that's just going to be equal to the price. So for a price-taking firm, price is equal to marginal revenue. What about on the cost side? Well, remember that our costs, which we gave before by C as a function of Q, that's going to be our fixed costs plus our variable costs, little c of Q. And remember that by definition, if we're looking at the short run, in the short run, the fixed costs are going to be, well, fixed. There's nothing you can do about them. It's going to be the variable costs that you can change in the short run. So our marginal cost is simply going to come from our variable costs. That's simply going to tell us how much extra it costs the business to produce one more unit. But we're also going to have average cost, and notice that we're going to have two average costs here. I'm going to call it average variable cost. An average variable cost is just simply going to be our variable cost, little c of Q, divided by Q. And we're going to have average total costs. And average total costs, well, that's going to be the whole of our costs divided by Q. So the average total costs are going to be equal to F divided by Q plus a little c of Q divided by Q. Now both the average variable cost and the average total cost, they're going to be at their minimum when they cross the marginal cost curve. That's because the marginals and average always cross when the average is at a minimum. But it's pretty clear to see that average total costs are going to be bigger than average variable cost. Why? Well, if you have a look at average total costs, that's got average variable cost as a part, but it's also got average fixed cost as a part. So average total cost is always going to lie above average variable cost in our diagram. Here we've got some axes. We've got dollars on the vertical axis and quantity on the horizontal axis. It's the little q, so it's going to be the quantity for a firm. I've labelled it here for firm I. Let's put the costs on first. So let's put our marginal cost on first. Our marginal cost curve, well, it might look something like that. And if you want to understand more about the shape of the marginal cost curve, look at our previous presentations. Now, let's put on the average variable cost curve. It's going to come down to a minimum at this point here, where the average variable cost and the marginal cost cross each other. And again, if you want to refresh your memory on that, look at our previous presentations. What about the average total cost curve? Remember that average total cost is just going to be equal to average variable cost plus fixed cost divided by quantity. So we know that the average total cost curve, well, it's going to come down. It's going to cross marginal cost at its minimum, like we've got here. And, let me just label it before I forget. We also know that this average total cost curve is going to get closer and closer to the average variable cost curve. The gap between these two curves is going to get smaller and smaller. How do we know that? Remember that we can write average total cost as simply equal to F divided by Q plus little c, our variable cost, divided by Q. But notice that that is the same as writing average total cost equals, well, this first bit here, fixed cost divided by quantity, we can call that average fixed cost. So average total cost equals average fixed cost plus, well, what's about the second bit? The second bit here is just our variable cost divided by Q. It's our average variable cost. So average total cost equals average fixed cost plus average variable cost. So this gap between the average variable cost curve and the average total cost curve, this gap in here, is simply average fixed cost, or F on Q. And as Q gets bigger, F divided by Q has got to get smaller because F is, by definition, fixed. It doesn't change with quantity. So the gap between the two curves is big out here and gets smaller and smaller as Q increases. Okay, so we've got our cost side covered. Now let's put on our revenue side. So let's pop a price on here. And, hey, this is as good a price as any other. I'm going to have that price by the dashed orangey sort of line there. And let me call that price P. It's a price-taking firm. So remember that the price is also the marginal revenue. And now we've got all the information we need to work out, one, what is a profit maximising quantity? You've seen that before. But now, two, what is the level of profit? Well, let's start off with the first question. What is a profit maximising quantity? Remember, a business, any business, maximises its profit when marginal revenue is equal to marginal cost. And that's given by this point here, where the marginal revenue curve crosses the marginal cost curve. So the optimal quantity for this firm is going to be given by this quantity down here. This is its profit maximising quantity. Let me call that Q star. Notice that for that level of quantity, the revenue of the firm, let me just write that in, the revenue of the firm at its profit maximising quantity, well, that's just going to be equal to P times Q star. So the revenue of this firm is going to be given by this large rectangle here. But the profit of the firm is revenue minus the cost. So we've now got to work out what is the cost of the firm. Well, that's easy to do. We've got all our information. What is the firm's total costs? Well, it's going to be average total cost, given by this purple curve, times its quantity. Average total cost of that quantity, well, let's put it on there. Average total cost for the quantity Q star is given by this dashed line. Let me put that on over here. Average total cost at Q star. That's pretty terrible writing, but you can see it. So, what's going to be the cost for this firm? Well, it's going to be average total cost times quantity, that rectangle there, the smaller rectangle. So, cost is going to be average total cost times Q star. Now, the profit of this firm is just going to be equal to its revenue minus its costs. So it's going to be equal to the big rectangle, price times Q star, minus the little rectangle, average total cost at Q star times Q star. So the profit of this firm is just going to be given by that difference, and that difference is simply this shaded rectangle here. What's that shaded rectangle equal to? It's just equal to the profit of the firm And the profit of the firm, as given by that rectangle, is simply price minus average total cost times quantity. That's just another way of writing our revenue minus cost equation. So notice that this firm is profitable. It's making a positive level of profits. Its revenue is greater than its total costs, and that's what we've called it, case one, the profitable business. But life isn't always meant to be easy. What happens if the price is less than this price here? What happens if it falls below average total cost? So let's look at this case. Same axes, dollars and quantity. I've redrawn on our marginal cost, average total cost, and average variable cost curves, but I'm going to choose a different price now. I'm going to choose a price that's way down here. That's going to be our price for our price-taking firm. That's also equal to marginal revenue. What's the profit maximising quantity? It's where marginal revenue intersects marginal cost. It's going to be given by that intersection there. So our profit maximising quantity is just going to be this value, Q star. Notice that the price is below both the average total cost and the average variable cost curve. So what's going to be the profit of this firm? Well, unfortunately, life for this firm is going to be nasty. It's going to have an average total cost above the price. Notice that immediately means that this firm must be making a loss, but it's also got an average variable cost above the price. Whenever you're in this situation, this is about as nasty and as mean as life gets. This is the case of a business that is not simply unprofitable, but it wants to shut its doors now. It wants to shut immediately. How can we see that? Well, notice that this firm is making a loss. Price times quantity, its revenue, is less than its total cost. Average total cost times quantity, and so it's making a loss. Let's shade that in. I'm going to shade in, though, in two bits. I'm going to shade this first bit in blue, and I'm going to shade the second bit in. Why don't we call the second bit red? So I'll shade it in red. Sorry for any of you guys who have red-green deficiency, that bottom one's red. So the total loss of the firm is given by the blue rectangle plus the red rectangle. But these parts of the loss have a different interpretation. Notice that the blue rectangle, well, what's the difference between average total cost and average variable cost times quantity? But you know what that is. Remember, the difference between the average total cost and average variable cost is just the average fixed cost. So this height is the average fixed cost times the quantity. Well, that blue rectangle is just simply equal to the fixed cost F. What about the red rectangle? Well, the red rectangle represents a loss that the business makes because it doesn't even cover its variable costs of operation. It's the difference between its variable costs and price. So this bottom rectangle is like the firm's operating loss. It represents the loss it makes by producing anything compared to its variable costs. So I'm going to call that its operating loss. Notice that this firm not only loses its fixed costs, but it also makes an operating loss when it produces the profit maximising quantity. It doesn't matter what it produces, it's going to lose its fixed cost. Well, they're gone in the short term anyway because they're fixed. But this firm, if it produces anything, well, it actually loses even more money. So the best this firm can do in the short term is actually to shut down. So in fact, this isn't the best the firm can do. The best the firm can do is back here at Q star equals 0. In the short term, this firm wants to shut down. Why? Because if it shuts down, it's going to lose its fixed cost, but at least it's not going to make an operating loss. The operating loss just makes its profits even worse. So this is a business that will shut down immediately. It will lose its fixed costs, but that's the best it can do. Let's now look at the intermediate case. We've drawn the curves again: marginal cost, average variable cost, average total cost. But let's now consider the case where the price of the firm, the price of this price-taking firm is, say, this line here. It's going to be P, but it's also going to be marginal revenue. Now, for that firm, what's going to be its profit maximising quantity? Well, easy, where marginal revenue intersects marginal cost. It's going to be this quantity here, Q star. If it produces anything, it will want to produce Q star. But as we've learnt from the previous example, we now have to ask the question, does it want to produce anything? Well, let's check. What's its average total cost at that quantity? Well, it's up here, it's above price. Damn, it's still making a loss. Average total cost at Q star is above the price. So we know this firm is making a loss. What about average variable cost? Well, average variable cost, it's less than the price. So average variable cost, Q star, is down here. What's the loss of the firm? Well, the loss of the firm is the difference between average total cost and price times quantity. So we can colour in the loss that this firm makes. It's going to be the blue area here. But does the firm want to shut down immediately? No. Remember that if this firm shuts down immediately, it loses its fixed costs. What are its fixed costs? Well, remember the fixed costs are the difference between average total cost and average variable cost times quantity. The fixed costs are the blue shaded area, the loss, plus the black area. That's the difference between average total cost and average variable cost times quantity. So if the firm shuts down immediately, it not just loses the blue rectangle, it loses the black rectangle as well. Or another way to think of this is the black rectangle, the difference between price and average variable cost, well, that is this firm's operating profit. This firm is actually making a profit compared to variable costs, prices above average variable cost. It's losing money overall because it can't cover its fixed costs. But it doesn't want to shut down immediately. If it shuts down immediately, it loses the operating profit. And if it loses the operating profit, it loses the blue and the black areas. If it keeps producing in the short run, then it just loses the blue area. So this is a firm that will operate in the short run. What about in the long run? Well, in the long run, remember, all fixed costs are variable. In the long run, the average variable costs are not a different curve. In the long run, the average total costs and the average variable costs are the same thing. So in the long run, when fixed costs become variable, the best the firm can do is to say, don't sign the lease again on the shop, don't rehire those employees. If we did that, we'd lose the blue area. In the long run, let's walk away. So in the long run, the business can save that blue loss by shutting down. But in the short run, the best it can do is lose the blue rectangle, because if it shuts down immediately, it loses the blue rectangle plus the black rectangle. And that's even worse. Let's summarise what we've learnt about short-run profit maximisation for a price-taking business. We've got three cases. If price is greater than minimum average total cost, if the price is above the average total cost curve, then you're going to produce in the short run and in the long run. You're making profits both in the short and in the long run. If price is below minimum of average variable cost, so the average variable cost is always above the price, you want to shut down in the short and the long run. The best you can do is lose your fixed costs. If you try and produce anything, that just makes matters worse because price is not covering variable costs. So you want to shut down immediately in the short run. What about if price is less than minimum average total cost, but is above minimum average variable cost? Well, in the short run, your choice is shut down and lose the fixed costs or keep operating. If you keep operating, you can't cover your fixed costs, but at least you're making an operating profit that contributes towards the fixed costs. So at least you can minimise your loss by operating in the short term. But in the long term, when those fixed costs become variable, you want to shut down. You certainly don't want to renew any of your fixed costs. You want to walk away from the business as soon as you can turn those fixed costs into variable costs. Because, hey, you are making a loss, and to minimise that loss, you want to get out of that business as quickly as possible. But as quickly as possible doesn't mean shut down immediately. It means shut down when the fixed costs have become variable when you're in the long run. Talk to you next time.